Okay, let's get dived in. How do you say that? Let's dive in. There we go. I like that one. Okay, so for this particular example, I'm going to start with the remainder theorem just to double check that that is indeed a factor. So when I plug that 2 in, it gets me a 0. So I am good to go. Now, because I can use the remainder theorem, I'm going to go ahead and do synthetic division instead of long division. If you prefer long division, feel free. I think in this particular instance, synthetic can be fast. And I'm just going to jump to the end. So if you need a review of synthetic division, go back to the lesson on dividing polynomials and watch one of those videos where I do more step-by-step walkthrough like that. All right. So we're going to start with the 2, write the coefficients, etc., etc. I'm expecting the remainder to be 0. It did equal 0, so I'm very confident that I'm moving forward. I'm going to take that quotient and identify it. Maybe the question asked for it. Remember, always 1 degree less than what we started in the dividend. The remainder is 0. Now I'm going to take that quotient and solve it. I'm going to double check it first, and then I'm going to solve it like that. So I'm going to multiply those two things out. I'm fairly confident that it's correct because I got the remainder theorem to equal 0, and I got synthetic division with a remainder of 0, but could have done something strange like that. So multiply through, put it together. That's the polynomial or dividend that we started with, and I'm good to go. Now I am going to set that quadratic equal to 0. And looking at it, I don't think it factors like that. Maybe it does. Try it. I don't think it does. I know it doesn't because I've already got the answer. So I'm going to go right to the quadratic formula. I'm going to simplify a little bit. I see a negative under the square root. Simplify that. I cannot simplify the square root of 71 any further. Those are my zeros. Those are my remaining zeros. Now, when we solve, remember, it's always good to double check, but come on, that is a crazy number to double check. I can write those zeros in factor form and multiply it through, and I should get that quadratic I started with. I can take these zeros and plug them into the original polynomial, and that seems like a tremendous amount of extra work like that. So just be careful when you do this. Values like this are extremely difficult to double check and probably more time consuming. Uh, so, all right, then make a list of the zeros like that.